Hello, in this video I'm going to talk about arithmetic progression. I'll start with a simple example. Start by looking at this sequence with the numbers 1, 2, 3, 4 and so on until 97, 98, 99 and 100. And now this is an arithmetic progression in the sense that you can get each number from the previous one by adding the same number. So if I add 1 to 1, I get 2. If I add 1 to 2, I get 3. If I add 1 to 3, I get 4, and so on. So that in a simple way is how we would describe an arithmetic progression. Now let's think about how we can add up all the numbers in this example. So let's say I want to add 1 to 2, 2 to 3, 3 to 4, and so on. I want to add the whole lot up until 100. Of course, I can add them one by one. I can use a calculator, but that might take a long time, right? Maybe all day. Is there a faster method? Okay, indeed there is. Now let's see if we can find some kind of a pattern to help us. One and 100. Now what if I add the first term to the last term? If I add the first term to the last term, I get 101. Alright. Now think about adding the second term to the second last term. 2 plus 99. This will give me 101 again. If I take the third term, and I take the third term from the end, 98. If I add 3 to 98, you see that I get 101 again. And the reason why we keep getting the same number is because if I go from 1 to 2, I increase by 1. But if I go from 100 to 99, I decrease by 1. That's why when I total them up, I end up with the same answer. So if I keep doing this, I'll keep getting 101 all the time. So if I keep pairing up the series this way, eventually I would end up with, how many pairs would I end up with? I would end up with 100 divided by 2 equals to 50 pairs. I end up with 50 pairs of number if I pair them up this way. And since each pair always add to 101, and since there are 50 pairs, therefore the total must be 50 times 101. That gives 5050. So this is a very quick way to get to the final answer. Okay. Now let me just make up another example. Now remember I described the arithmetic progression. Oh, by the way, I'm going to use the abbreviation AP for arithmetic progression from now on. AP. It's quite a mouthful to say arithmetic progression all the time. Takes up quite a number of seconds to say that. So I'm just going to say AP. Okay, let me just make up another AP just to get used to the idea. Let's say I start from 2. Okay, and this time I'm going to add 3 to 2. So if I add 3, I'll get I get 5. Add 3 to 5, I get 8. Add 3 to 8, I get 11, and so on. So this is an AP as well. So what I like to do next is to obtain or derive a formula for say the sum, right? For the sum of an AP, and I would also like to derive a formula for a general term. All right, let's say I want to find okay, that one is easy. But let's say I want to find, say, the number 20th term of this sequence. It's not entirely obvious what it is. I might have to write out the terms one by one until I reach the 20th term. That's a bit tedious, especially if I decide to find the 200th term. Right, that's going to take a while. So, and it would be nice. So it would be nice if I can have a formula for any term. So in order to get formulae, we need to represent these numbers by symbols. So let me start doing that now. Now I'm going to represent the first term by A. Okay, so let me write out the meaning of A. So I'm going to let A be the first term. And remember that for this sequence, for example, I have to add 3 to each number to get the next one. Okay, so I'm going to let I'm going to represent that by the letter D. D would be the number that I have to add each time. Now D is called the common difference. And the reason why it's called a difference is because we can get D if we subtract each term by the previous one. So 5 minus 2 is 3. 8 minus 5 is 3. 11 minus 8 is 3. So it's always the same difference if I subtract a number and if I subtract a number, the two adjacent numbers. And the reason is simply because I get each number by adding 3 to the last one. Okay, so D is 3 in this case. And as I said, what I like to do is to get a formula to help me to find any term I like. So let's say I want to find the R term. Now what do we mean by the R term? I'm using R as a symbol, R, to mean the order of a term. So if R is 1, it means the first term. Write it out. If R is 1, is the first term. If R is 2, is the second term. If R is 3, is the third term, and so on. So R is the order of the term, and I'm going to let the Rth term be represented by the symbol TR. So this T just stands for term, and R here would refer to the Rth term. So for example, that would be T1. Alright, T1 would be the first term, T2 would be the second term, T3 the third term, and so on. So it would be nice if I can have a formula, if I can make a formula for TR that would allow us to find any term we like if we pick an R. Now to see what these terms would look like, what this formula might look like, let me write out each of these terms in terms of A and D. and see if we can find some kind of a pattern. Okay, so 2 is A, right? So that's A. And 5, I got 5 by adding 3 to 2, and 3 I'm representing by D. So 5 is actually A plus D. A plus D. And to get 8, I have to add D again. So it's A plus 2D. I get this by adding another D, so it's A plus 3D. Now notice something. The ordering number R. Okay, when let's say when R is 3, I have 2D down here. When R is 4, I have 3D. When R is 2, it's just the 1D. So the number of Ds is always 1 unit less than the value of R, right? Or the ordering of the term. And this is the pattern that we need. So for example, if I say I want to find the R term, TR. If I want the R term, okay, the R term. So what would be the formula? Well, since we have noticed that from this pattern, that this number that multiplies the D must always be 1 unit smaller than R. That's exactly what we can write down. A plus a number which is 1 unit less than R, and that is just R minus 1 times D. So in this way, we've just found our formula for TR. So TR therefore must be equal to this A plus R minus 1 D.